terminating the process. So so basically disposal of solid waste is done commonly through the sanitary landfill or through incineration. However, if I have to give you the different methodologies by which you can do the disposal procedure, so we have uncontrolled dumping or non-engineered disposal. Mostly you will see in the rural side this kind of site where in non-engineered manner simply wastes are dumped. So those are called dump yard or uncontrolled dumping or non-engineered disposal. Next comes the sanitary landfill. So these are the engineered landfill which we'll be discussing in detail. And in these days, in most in urban areas, you will see sanitary landfill, and this is the smartest way to handle bulk quantity of waste for disposal. Next, another one option could be composting. So this is another one biological process of decomposition, and these days people are talking about decentralized composting, so that everybody can construct one composting facilities at their own premises or at their own courtyard, so that the solid waste which will be generated after that composting process would be lesser in quantity, and as well as it will be less toxic or hazardous, and you will get a humus like material which is environment friendly, or that's basically the converted organic portion. So this process is very effective. However, it is not largely adapted in our country. There are some problem people have that mind not to do composting plant at their premises. So because of so many cultural and mental blockage, this procedure is still now not adopted in large scale. Next, we have incineration. So basically, this is a controlled burning of the waste at higher temperatures. So this is 1200 to 1500 degrees centigrade you apply, and then you have gasification, you have pyrolysis. So in pyrolysis, it's basically the degradation of carbonaceous material to gaseous, liquid, or solid forms, and pyrolysis happens in the absence of oxygen. So that's the main difference with incineration. Many a time you may encounter a question, what is the difference between incineration and pyrolysis? So the main answer lies in the fact that in case of pyrolysis, you don't need oxygen. The pyrolysis process is conducted in the absence of oxygen, and usually the temperature is also lesser with compared to the incineration. In this case of pyrolysis, we have temperature from 200 to 900 degrees centigrade, and the product of pyrolysis is basically gas which are having relatively higher calorific value, so around 20,000 joules per gram, and then you can have some oil, stars, and solid bonds residue as well. So these are the different ways of and for each and every options, disposal options which I have talked about, has some inherent merits and demerits, and depending upon that, once you are given a responsibility, you can take the best suited disposal option. However, it has been observed, considering the different type of solid waste which is produced in our country, and concentrating on the composition in the urban area where the quantity of solid waste, the generation of solid waste is huge. It has been observed that that sanitary landfill or engineered landfill is the most effective way of disposal, and that is why in today's class we'll be discussing in detail about the sanitary municipal sanitary landfill, and what are the difference with municipal solid waste landfill over the open dump yard, and what are the advantages over the dump yard. That those things also we'll discuss in today's class. So there are several reasons to choose a particular type, as I mentioned, but here if you see, I have actually mentioned 3 points. Solid waste is placed in a suitable, selected, and prepared landfill site in a carefully prescribed manner. The waste material is spread out and compacted with the appropriate heavy machinery, just to reduce the volume and increase the density, so that the service life of the particular landfill can be enhanced or increased. Now, the third point says the waste is covered each day with a layer of compacted soil So what it does is, basically, so the next day when you start, so you can create from the top of the compacted soil. So that has different, inherent advantage. It will create less, uh, disturbance, because the waste will not be blown away by air. It will not be accessible to the, stray animals. And then there are several other advantages associated with that, and that is why every day the waste is covered. So we basically create compartment of waste within the landfill itself. So with this, now we'll slowly move to the systematically engineered landfill. So if you see this landfill minutely, you will be able to observe few things here. So we have, when we have a landfill site, basically that is a depressed part. So we need to create the depression either by digging, or if we have a low land that can be utilized for this. Now, after that, we need to create a proper isolation. So how this isolation is done? So that isolation is done by the help of liner material. You can see here in the right hand side bottom, we have the enlarged section of the liner material at the bottom. So what it consists of? It consists of gravel, and then you have geotextile or fiber plastic membrane, then mineral layer, you have bottom refill, and then again geotextile fiber, and then you have clay. So this entire thing is basically the bottom layer, which actually ensures uh, that nothing leaches out from this landfill to the ground or soil beneath. Because if you see, we have the groundwater drainage, we have the groundwater table, and if something leaches out in the form of leachate, which is toxic and hazardous at the same time, can contaminate the groundwater table or the entire aquifer for that matter. And you know very well that once aquifer is contaminated, it is quite impossible to decontaminate that aquifer. It is very, very cost exhaustive process, and usually we don't prefer to do that, and hence we try to avoid that by creating an isolation, by providing such kind of liner, which is a multi-layered material of different types of you know components, and that can ensure that nothing leaches out from the engineered landfill. Now once that is ensured, now we have several compartment, and then at the same time we have several network of pipes. Now there are two things. One is the leachate which will be generated has to be collected, and then the gas will also be generated, because once you are closing the top, and then there are no provision of oxygen entering into the system, it becomes anaerobic. And once you have anaerobic decomposition, you will actually end up having some gases generated, like carbon dioxide, carbon monoxide, and most significantly methane. Now once you have all those gases getting generated within the landfill itself, so you need to take them, you need to have proper system to collect them or to diffuse them in the atmosphere within the limit, or within the permissible limit of concentration. And for doing that, we have the gas wells, and those gas wells are connected by the gas pipelines. Now you have sometimes those gas, if it is in significant amount, can be collected and can be used for some other purpose, or you can simply take that gas to produce electricity. I mean, you can basically transfer that energy in whatever way you want. And apart from that, we have a leachate collection system, so that pipeline is also there. And then you start filling from the bottom, and then you can see that garbage stratification has been done. And then once the final layer is already placed in the landfill, after that we'll have a top cover. In order to create proper isolation, we provide liner at the top. So top liner is also provided, and then at the top of the top liner we'll have some beautification or grass lawn or something of that sort, so that nothing is visible from the top, and no foul smell is getting emitted from the top. So that area can be utilized, since it's a vast area, can be utilized for amusement purpose. You can construct park, you can construct something else. And this is the way systematically engineered landfill work. And nowadays, if you see in most of the metro cities, if you go there, you can see that in the vicinity of those metro cities, you have bigger landfill, which are obviously engineered landfill and municipal solid waste landfill. And now these days, another one state of the art technique has come, that is a bioreactor landfill. So you have additional facilities to recirculate the leachate which is getting generated, thereby enhancing the decomposition rate. So these are the different ways you can increase the efficacy. And there are so we have certain time period for constructing the landfill, for dumping the landfill, and then keep it for the entire decomposition. And after that, you can do landfill mining. So this is the entire process. All those details are not required, but several components, how they work and what are the purpose, those things actually should be understood here in this case. Now with this, if you have any question, I'll ask, you can ask or I'll answer, or otherwise we'll move to the next part, our leftover part, that is the sewage disposal, which I'll be discussing next. So just go to the next part. So sewage disposal, mostly, if I say sewage disposal, basically sewage disposal, this can be done in two different ways. Fine. So uh, one is natural, another one is artificial. Now basically artificial is the treatment. Fine. So artificial is basically the treatment, which we will be discussing in subsequent semester. So in treatment, we have primary, secondary, tertiary, and so on. So we can write primary and secondary. And right now, this is not the uh, portion which we are bothered about. Rather, in natural method, we have two popular methods which we'll be discussing in today's class. One is dilution into water, dilution into water. Another one is land treatment, land treatment. So these are the process which we will be discussing in today's class. Now what is this you know mm, disposal by dilution? So basically what happens is, in this process, the raw sewage of the partially treated raw sewage or the partially treated sewage is thrown into the natural waters having large volume. So compared to the volume of the water, the portion of sewage which are actually disposed of is negligible or very less. That is why it will not create any harm to the quality, to the entire water body. And the sewage in due course of time is purified by what is known as self purification capacity of the natural water. So several small mechanism or biochemical reactions will go on in a natural water bodies, and that will actually reduce the harmful concentration of the sewage, and then thereby it will purify itself. Now the limit of discharge and degree of treatment of sewage are determined by the capacity of self purification of natural waters. Fine. So this is the overall process. It is better to hear and accordingly take notes, because I am not going to dictate, or you are not going to write here in this class. So there are some conditions favorable for dilutions. Fine. So favorable conditions for dilution, let me write this. So favorable conditions for dilution. So the first one is, it is possible only to provide primary treatment to sewage. So removal of floating material and settleable solids is the favorable conditions for dilution. So the first one is removal of floating matter and set level solids. Removal of floating matter and set level solids. Next is currents of flow. So currents of flow of diluting water should be favorable, which means that nuisance should not be caused when sewage is discharged into the diluting waters. Otherwise, if there is a change in the nature of flow, so then that will create some problem. So that is why you need to remember this, currents of flow. Now, diluting waters are not used for the purpose of navigation for at least some reasonable distance on the downstream from the point of sewage disposal. See, again, that will create some disturbances. So, no navigation in downward. Fine. Number 4. Now, diluting water should not have habitation, or they should not have been used as source of water supply. So, should not be used for water supply. Fine. So what are the different type of natural waters where we can have creeks, we can have groundwaters, we can have lakes, ocean, perennial rivers or streams. So these are the different water bodies where actually we can uh, put this water for sewage for dilution. Fine. So another one important thing which has to be kept in mind is, while discharging sewage in water body, it should be ascertained that water is not polluted to such an extent that it becomes unfit for any other use. So that part actually has to be kept in the mind. Now, diluting water must be rich in oxygen content for dilution. So otherwise, again there will be higher oxygen demand, so which we don't want. Fine. So now the next part which we'll be talking about is now the next thing is self purification of natural water. So how this is done? So when just listen to this, when sewage is discharged into the natural water, its organic matter gets oxidized by the dissolved oxygen content present in that water. Fine. So the oxidation of the organic matter converts such matter into simple inoffensive substances. So that is why decomposition is important in the presence of oxygen. Now, deficiency of dissolved oxygen thus created in natural water is filled up by absorption of atmospheric oxygen, and therefore the oxygen of water is consumed by the sewage, and at the same time it is replenished by the atmosphere. So this is the natural process. So this phenomena which occurs in all natural waters is known as self-purification of natural waters, and this is what actually we are expecting from this natural. So what you are doing is some concentration of unpurified water you are simply putting in the water bodies, and then let it give some time so that naturally it can heal itself. So this is a process when we talk about one of the very important process. And next is disposal by land treatment. So we'll be talking about that. Disposal by land treatment. So what happens is, in this case, the raw domestic wastewater or sewage is applied on the vast land. Fine. A part of the sewage evaporates. All of you know that. So the once the surface area is huge, so there will be a enhanced evaporation. Because of that, a part of the sewage evaporates, and the remaining portion percolates to the ground and is caught by the underground drains for disposal into the natural waters. So this is a natural process which happens once a particular liquid is thrown out from the surface. Some portion gets evaporated, and the rest of the portion go in the grounds and percolates. And during the process, all those impurities get arrested or get caught by the soil skeleton or soil particles. Now the sewage adds to the fertilizing value of the land and crops that can be profitable from that particular land. And the terms sewage farming is also sometimes used for indicating disposal of sewage by land treatment. And the design of a good land treatment system demands the services of environmental engineers, hydraulic engineers, irrigation engineers, agronomists, soil scientists. Fine. So again, we need to see what are the favorable conditions for land treatment. So we now talk about. So the area of land treatment is composed of sand, loamy or alluvial soil. So fine. Why this kind of soil? These soils are basically will have more pores into it, and that's why it will have more aerobic conditions present into it that would help in decomposition or aerobic decomposition. So the depth of the water table should not be huge, even in rainy season. It should be less, and so that there are no chances of pollution of underground water source by land treatment. So basically, we have to ensure that these water bodies are shallow water bodies, and there is no direct link with the groundwater table. So we can write here shallow water bodies. Fine. The rainfall in that area is low because if the water does not have the soil does not have higher absorption capacity, then the efficacy would be in question. So that is the reason when we talk about the disposal by land treatment, it is suitable in those areas where the rainfall is not very high or huge. So rainfall is low in those particular areas, and there is absence of river or any other natural water resources in the vicinity of the disposal sewage. So no natural water body in the vicinity of the disposal site. Fine. And then finally, large open area, because we need more surface area. So we need to have large open area. So in the surrounding locality, we can actually do the irrigation by the sewage also once it is treated. Now there are few merits of the this particular technique, merits or advantages. We can discuss them. So it increases the fertility of land. Number two, it is cheap where land is available in plenty. Cheaper method. Number three, so directly what we are doing is that we are applying sewage to the soil, and thereby we are supplying manure to the soil. So this is the best method for supplying manure to the soil. Supplying manure to the soil. Fine. Now it has been observed that the crops will have more nutritive value, like the content of vitamins and calorific value will be high, which are grown in this treated land. So crops will have high calorific value and vitamin. Fine. Next, this method actually very useful at places where disposal of sewage by dilution is not possible. So that is another one advantage. Now it does not need any costly equipment. Does not need any costly equipment. That is another one important advantage. And this is an economical and safe where available irrigation water is scarce in quantity. So this can be written as economical and safe. Suppose you have scarce of water for irrigation, so these sewage can be utilized the way we have discussed. Now once, and sometimes what happens is this actually recharges the underground aquifers. How once it percolates, most of the harmful material will get arrested in the soil, and then finally the water will be percolated, and then it can somehow recharge the aquifers, and water of irrigation canal can be saved by doing this practice. So water of irrigation canal can be saved. So whatever I have discussed, whatever I have written, just remember them. They are important. Now there are a few demerits. We need to discuss them. So you can write demerits. Basically, if you don't take proper precautions, then it can create some nuisance, because it can create some hazard to the human health, and that is why it is necessary that the sewage farms should be operated under skilled technical supervision, and it should be away from the locality. Right? So one is it should be operated under skilled technical supervision, and it has to be away from the danger to the human health. Number two, what happens is this: there is a psychological problem. Crops grown on sewage farms are generally not liked by ordinary public. So this is a psychological problem. Fine. I mean, there is no as such problem as far as nutritive value and vitamins are concerned. Even it is beneficial, which we have seen. However, this psychological problem is there. Number three, this method is not applicable for all the seasons of the year. In monsoon, some other arrangement of sewage disposal has to be found out, because in monsoon, all those processes will not happen, because the absorption capacity will not be as high as in the dry season. So you can write not suitable in all the seasons. Number four, it needs large area. Fine. Large area of land is not available all the time, so that can be considered as one demerit. And then we have types of crops are limited. Actually, we can only grow few different types of crops. Types of crops are limited. Now, another one important term which we should discuss in this context, that is sewage sickness. This is a very important term. What is sewage sickness? If sewage is applied continuously on a piece of land, pores or voids of soil which are filled or clogged, so free circulation of air is thereby prevented. And these aerobic conditions which we have been talking about so much now gets converted into anaerobic conditions. And at this stage, the land is unusable to take any further sewage load. Now, organic matter decomposes and foul-smelling gases are produced during that point. So that has to be actually understood very well. Now, this phenomenon of soil is known as sewage sickness of land. Fine. So this is also, you should remember what is sewage sickness. So you have to ensure that once you are doing this process of land treatment by sewage or sewage farming, you have to ensure that the soil does not get that sewage sickness. Because if sewage sickness happens, then you have to again go for the preventive measures, and there are several preventive measures. And that has to be the rotation of crops, treatment of land, pre-treatment of sewage, those things, drainage of soil. So those things has to be done. And if your entire sewage treatment is dependent on this kind of system, and then if you encounter sewage sickness, then you need to arrange alternative process, and that is a very cost extensive procedure. So that is why this sewage sickness always has to be kept in the mind, and you have to see that soil does not reach to that extent of sewage sickness. Fine. So with this, we will complete the part of the module. Now let me go back